Some people try to make programming easier. But Vivian is trying to make it harder. Go for it.
Hi, good afternoon. My name is Vivian. I am a PhD student in Berkeley, from Berkeley. And this work is done by me and my co-first author, Shaori, who was a student in Berkeley and now is a first-year PhD student in UPenn. And this work is advised by Sarah. And so in this work, what we really want to understand is the relationship between natural language processing and code understanding. So think about this scenario. A user who is kind of a beginner, kind of has some experience in coding, wants to light up an LED with Arduino. And as the user goes to ChatGPT and just be like, okay, how do I light up an LED with Arduino? And ChatGPT generates a piece of code, gives some description of what it's trying to do, but what the user doesn't realize is that there are some assumptions that are baked into this code. For example, what type of LED is being used? A LED strip and a single LED and a built-in LED in Arduino is very different, but the user just doesn't know. And so now the user is kind of frustrated. It's like, it's not working, like nothing's showing. So the user being stuck with a piece of code that is supposed to work, but doesn't really work quite right, and gets really confused and doesn't know what to do next. Like, do I debug? Do I start over? The user just doesn't know. And so there are more and more evidence showing that people don't really understand their own code anymore. Terms such as AI slop, like vibe coding, kind of just shows that this is becoming a trend in just a lot of people. And so a lot of research actually has talked about how do we code with LM, what is the relationship with human and LM? Like, how do we prompt them? How do they understand each other? But none of them really focus on how it affects code understanding and later editing the code on their own. And so our research question is, does natural language programming necessarily sacrifice code understanding? With this, we kind of have two hypotheses. The first one is natural language is inherently ambiguous. So if the user only interacts with natural language, the user will never really resolve these ambiguities, and so they never reach a full understanding of their code, which sounds kind of sad. But the next hypothesis is natural language tools present single-point solutions which never force users to resolve ambiguities. So if that's the case, a natural language tool may support later editing if, first, it preemptively decomposes programming tasks, and secondly, if it asks users to resolve the uncertainty about the decomposed subtasks. But now looking back at LLMs, which is, let's use ChatGPT as an example because it's so commonly used, does it decompose the code for the user? No, it kind of just provides a piece of code. And does it surface the decision? It may or may not, but no guarantees, and also the user might not even look at what is being decomposed. So the short answer is no to both. And so to explore this further, we designed a simple study tool for programming with Arduino that uses natural language, but in a different way. This is how the tool kind of looks like. So the user starts with choosing what kind of component they want to use. And based on which component is being chosen, there is a set of questions that the user needs to answer. And the system also guides the user through defining the relationship between components and just generally what kind of behavior the user expects from this program. And then with that, the system generates a piece of code that is directly mapped from whatever the user answered in the previous set of questions and map that into a piece of code. And some quick side notes is that if you're interested in how we generate these quiz web shapes, you can come to Carnegie later. And although we focus on Arduino because of our task, but the framework should be general. And there are a lot of plug and play additional components, so it's not hard coded. And so with this, we decompose the question, the decisions, and we surface the decisions for the users. And we kind of, in short, talk about it in prompting and answering mode. And next, so we designed a user study, which we want to answer these questions. So in these two different kind of tools, how does it change the drafting time to draft a piece of code and the perceived workload of it? And next, when we remove the tool, how do they modify the code? Does the time required to modify the code changes? And does the behavior in the participant changes with these different tools? And this is the kind of task that we do in the user study. So the user would observe this kind of task, and then will be given the hardware and would be asked to come up with a piece of code, draft a piece of code with a tool, that like works exactly the same, or it works the same as the shown video. And so this is the way the user study is structured. On the left, we have an easier task and we have a harder task. And with each of the tasks, the user first start with drafting a piece of program with one of the tasks. And then from there, we remove the task. So now the user is on its own, and they need to solve 3 editing tasks, which the editing task could be as short as just one single variable, or entering a few, like 2 lines of code, and the task also gets a little, gradually get harder. And so now look at some quantitative result. If you look at drafting task time, so there's a little bit, user is a little bit faster with the study tool, but with the easy task. But if we look at the harder task, the user is 11.9 faster when they're using the study tool. Well, looking at their reported drafting workload, there's minimal effect for the easy task, but the user report higher workload when using ChatGPT for the hard task. So keep in mind the result where the user spend more time on ChatGPT and say that it is harder. And so now we remove all of the tools, right? The user is on their own, and we see minimal effect for how much time they spend on editing the code that they made with the tool earlier. And so there's minimal effect for the easy task. But now we see with the study tool, it's actually a lot faster than when they're using ChatGPT. So remember earlier we said that with ChatGPT, when they're drafting the code, they spend a lot more time, they report it's harder. Shouldn't that mean that they actually build up some understanding through the more time and more workload? But clearly with the result of them spending a lot more time editing the code that they generated, that is not the case. So back to the question, does natural language programming necessarily sacrifice code understanding? No, because in our study tool, it's also natural language, but the user still kind of understood it better. And so with these, we kind of just see, no, natural language isn't really, the issue here. So let's look at some qualitative results that we kind of observed through this study. These are some of the main trends that we observed. And each of them, there are like a lot of examples that shows, for example, users didn't really comprehend the code and the descriptions that ChatGPT generated for the users. For example, one of the users spent a lot of time trying to solve one of the, resolve one of the variable that they feel like would be the issue. They spent a lot of time, like 12 minutes. But then later on, when they were left on their own to edit it, they still did it wrong. They completely misunderstood what it was about. And they would discard previous versions of code. Only one user ever tried to debug the code that ChatGPT generated out of the 12 users. And they would debug non-bugs, which is like, we already told them the hardware works. There's no issue in the hardware. And the user kept asking ChatGPT, and ChatGPT was like, no, then your wiring is wrong. And then the user just like asked us, is this like a test to see like, am I really supposed to believe you guys? But this is an actual conversation. And then last, they grounded shift from being a collaborator to operator. They they will start with, oh, like, can you tell me this and help me with this? And later on, they would just be like, it's not working. It's still 0. You're not clear. And they get really frustrated too. And participants who use our study tool, they show that they build a mapping between their design decision and the portions of source code. So one of the examples that was really fascinating was the user, without being asked to do any of this, they actually went to repeatedly prompt our system and to generate different pieces of code, and they were actually trying to learn from it. And from our post survey, they also reported that the system showed them options that they weren't aware of. And so lastly, we want to talk about some of the implications for designing natural language programming authoring tools that wouldn't sacrifice later editing, which are these 4 points to make user wrestle with decision explicitly, even when the default seems obvious, to break design decisions into bite-sized chunks, to explicitly enumerate allowable alternatives during program design, and to generate code design to be read. Thank you.
All right, 3 minutes of smoke.
We talk about coding agents and how the modern ones all have this plan mode where they ask you clarifying questions. questions, and it appears to be fairly well done. And it seems like that aligns pretty well with your approach here. We also talk about the choice of a hardware-based environment, which is somewhat smart because the usual angle of attack would be, well, the agents just do this. You don't need the custom tool. But if you have hardware, the agents can't verify. Was that a deliberate choice while setting up this project?
So kind of the actual way it developed was that we started with the interest of helping user code with Arduino, and then we ran a formative study on designers or even people who code but in a less experienced level, and how they code, and we observed and then found some trends, and then we thought it would be interesting to look into that aspect specifically. What was the tool that you mentioned?
Basically all the agents do this.
Like
One
this.
does it, Codex does it, the platform thing.
Okay. Yeah.
What version of ChatGPT were the students using for that condition in your evaluation? Was it 4.0, 5, 5.2?
No, it was earlier. I think it was
Earlier.
3.
Oh, okay.
Yeah.
So this is very outdated. The results.
It was roughly a year ago. Yeah, a year ago.
What do you, obviously if you hand code the set of questions, that makes it a lot more likely to be accurate. What do you think the options are for having the AI actually generate the questions so that it could be a more general purpose kind of approach?
Yeah. That was actually something I was just sketching down in my notes earlier. I do think generative interface has crazy potential for this. And as you mentioned before, this is done in an earlier version of ChatGPT. So definitely, I think that's a really, really interesting future direction.
Okay, let's thank Vivian.